guys, welcome back to Layla Teachers. Today we'll do reactions of benzene, but first we'll start with a homework from the last video. So the first question was the reaction of butane and iodine. So we know that butane is an alkane and they undergo substitution reactions. So here we have butane plus iodine. It will only add one iodine to the alkane and hence we get iodobutane plus hydrogen iodide. You can write one iodobutane or just simply iodobutane because it's only one functional group. All right, our second question was you had to complete the reaction. So you were given an alkene. I say alkene because we have a double bond and you had to hydrogenate it. So we were given pentene, right? We had two double bonds. We had the addition of hydrogen. And because we have two double bonds, we will need two molecules of hydrogen and hence we get pentane. And our final reaction, final question, we had to show the chlorination of propene. So propene's got a double bond. You will break the double bond because alkenes, they have addition reactions. Once you break the double bond, you're going to get two chlorine molecules, one on each carbon that initially had the double bond, and then you're going to get 1,2-dichloropropane. Okay, starting with today's lesson. In a previous video, I did speak about the effect of benzene. Now, benzene is a conjugated system. It's a cyclic structure, closed system, and because of the three double bonds that it has, there's delocalization of the electrons, and this produces a resonance effect, a mesomeric effect. And because of this, benzene tends to undergo electrophilic reactions. Okay, benzene can undergo several reactions. We will start with halogenation of benzene. Once again, halogens are fluorine, bromine, chlorine, and iodine. So benzene has three double bonds. It's like an alkene. You can choose any double bond that you like. I would suggest the first one on the top. So if you have bromination, you will have one hydrogen and one bromine. It acts as alkanes because the double bond is quite strong. You will not be able to break the double bond. Instead, it will react like an alkane. It will just be substituted instead of addition. And another product is hydrogen bromide. So here we are going to get bromobenzene. Okay, number 2 is sulfonation of benzene. Now, sulfonation of benzene is with sulfuric acid. It can react in any point. You will get an SO3. The hydrogen that was already at that third carbon goes at the end of the compound, and this will be sulfobenzene. It is also known as benzene sulfonic acid. Here you can see the reaction. The third type of reaction is alkylation. If you remember, I told you alkyls are CH3 compounds like CH3, CH2, CH3. This is methyl, propyl, butyl, for example. So when you react benzene with, let's say, chloromethane or an alkyl halide, then you will get like methylbenzene or alkyl benzene, right? What's important in this reaction is that you need to have aluminium chloride, which is the catalyst, which initiates this reaction. And here we'll get methylbenzene, and as a side product, we get hydrogen bromide because the bromine of the alkyl reacts with the hydrogen that was initially in the spot where the methyl is now. So this is how it looks. Okay, reaction number 4 is acylation of benzene. I will speak about acyl chlorides or bromides in another video, but you need to know that acyl chlorides is is an acetic acid with, instead of the hydroxyl group, it is replaced with a chlorine, and it is very extremely reactive. So when you react benzene with an acyl chloride, you're going to get HCl, the side product from the H that was already at that point where the carbon will attach, and the Cl from the acyl chloride, and then you're going to get an acyl benzene. So the C double bond O will lose the Cl and react with the carbon in the benzene molecule. Okay, the fifth type of reaction is nitration of benzene. So nitration is you take in nitric acid, which is HNO3. So it reacts in a very similar fashion to sulfonation of benzene, and you just get an NO2 on a carbon, let's say the second carbon, and you will get a nitrobenzene. And once that happens, you're going to release water, because you have one hydrogen from nitric acid, one oxygen from the same acid, and then one hydrogen already from the spot where the NO3 fits into. And this is what the reaction looks like. Alright, so when you add one hydroxyl group to benzene, you're going to get phenol. And it is quite similar to benzene in terms of reactions. But when we speak about halogenation or nitration of phenol, it is slightly different to benzene, because instead of going into just one carbon, it splits into 3 different carbons. I'll show you how. For example, if we have nitration, if I add nitric acid to phenol, it's not going to be 1 carbon, but 3 different carbons, and you're going to get 2, 4, 6 trinitrophenol. So this is the difference between benzene and phenol reactions, but they both have mesomeric effects, and they're both electrophilic. Okay, we need to speak about positions with regards to the cyclic structure of benzene or phenol or just aromatic compounds. So we have 3 positions. We have ortho, we have meta, and then we have para. So ortho is, remember, 1, 2, para, remember, 1, 4, and meta, remember, 1, 3. So what does this mean? So when you have a cyclic structure, if you have a functional group on the second carbon, you definitely have a functional group on carbon 1, and keeping that in mind, when you have a functional group on carbon 2, it is going to be ortho. If you have it on carbon 3, it's going to be meta, and if you have it on carbon 4, it is going to be para. For example, if I have a Cl in the carbon 2, it's going to be ortho 1,2-dichlorobenzene. Alright guys, let's move on to the homework for today. I will give you 4 different questions. So the first one is, you have to show me the bromination of phenol and name the product. Question number 2 is, show the reaction between chloroethane and benzene, and you have to name the product again. Question number 3 is, show the iodination of benzene and name the product. And the last question is, show the hydrogenation of benzene and name the product. So this is it for this lesson. I will see you in the next video. Take care. Bye.